In this particular lecture, we're going to have a look at viewports within games, and they effectively, we can think of them as a window into our game world, and whatever falls within that window is what we draw to the screen. Viewports are very commonly used, and certainly we will need some way of, if we do have a large world which is not all visible on the screen at a point in time, we'll need some way of actually determining which bits of the world that we draw at any particular instance in time. And this is where viewports will come into it. We can also have, or extend the notion of the viewport to this screen as well. In most cases we're drawing to the full screen, but if we had a split view or a side-by-side view, we may want to draw one window within our game only to one particular region or portion of the screen. So viewports can also refer to, we were talking about in terms of the layer or the world, but also a screen viewport is the region of the screen that we are drawing to. In terms of definition, most commonly viewport's a window into a game world. Any objects that fall within the viewport are ones that are visible, and then ones that we will draw. The viewport, it is generally something that can move around, and sometimes you may leave the movement fully within the control of the player. Other times the movement may actually be tied into a particular key character that the player, him or herself, is moving around, and as the character moves, the viewport moves to always keep that character visible. But there's fairly standard uses of viewports. Different ways that we can define a viewport. We're going to look at two of them here, and to be honest, they're going to make our life slightly more complicated in as far as when we are sort of wanting to draw things, and then when we're wanting to think about our viewport within a layer, there are different ways that we would like to conceptualize or to think about the viewport, because it makes certain tasks more difficult or more easy to do. So I'll show you two ways here that we could represent a viewport. One way is in terms of 2 points, where we have a top left point and a bottom right point. And they define the two extents of the particular box in 2 dimensions. And when we're drawing images using the Rect class that we have within Android, this is the coordinates system that we will be using, because that's what it is based on. Another way of defining it is to give it a center point, and also then to give it a width and a height. And quite often, if we are thinking about a viewport as a window into a world, it's convenient to think about, well, where's the center of the viewport and how big is the viewport? And if we want to move it, we just update the center locations for it. So 2 different ways of representing or modeling a viewport, and we'll end up using both of these. The notion here is that if a game object falls within the viewport, then it's visible and we draw it out. So here we've updated our world now to have a Mario character. Mario is partially within the viewport and hence should be drawn. And we want then to say, okay, how can we work out if a game object falls within the viewport? And assuming here that we are using a way of representing our viewport and representing our objects in terms of saying, well, there's their center point and there's a width and their height. This representation. One thing to point out about Mario, and this is a potential source of confusion, but it's one we want to keep in mind. We are talking here about the size of Mario within our world. So our world might be 1,000 units wide and 100 units high, for example. And we can give Mario's position anywhere within that world. And we might say that Mario is, for sake of argument, 1 unit wide within our world and 2 units high. So that's when we're talking about the width and the height here, we're talking about the width and the height of that character within the world. When we're drawing Mario will, in this case, we'll have a bitmap. That bitmap will have a width and a height itself, and that is secondary to this. When we're drawing things out, yes, we'll take it into account, but here we're thinking about notionally the bound, the size of Mario as an object within the world, not necessarily the size of Mario in terms of how big is the bitmap that we'll use to draw him. Now, given this setup then, the little fragment of code that we have shown here is all that we need to work out if an object falls within the viewport. It's worthwhile taking a little bit of time to go through this. You can see here there's a number of conditions, or less than or equal to or greater than or equal to. There's 4 of them, and we're ANDing them together. And if all of them are true, then Mario is visible. And by implication, if one of them is false, then Mario is not visible. And as soon as we get a condition where Mario isn't visible, we'll stop that particular evaluation and exit out of the if. So if we want to think about, well, what types of situation would mean that Mario isn't visible? And if you think about this here, so we're looking at Mario there. If the right-hand side of Mario, so if you were to think of Mario having a top, a bottom, a left, and a right, and if the right-hand side of Mario, the rightmost point, if it was less than, so in terms of its x coordinate, it is less than the left-hand side of the viewport. So again, the viewport will have a top, bottom, left, and right. So if Mario's right-hand side has an x coordinate which is less than the left-hand side, it means that Mario notionally ends along the x-axis at some point before the viewport actually starts. So in that particular case, Mario couldn't possibly be visible. Equally, if you look at the left-hand side of Mario, so this is where Mario starts along the x-axis, and you were to look at that coordinate compared to where the viewport ends along the x-axis. So if the start of Mario is after the end of the viewport, then that's also a condition which would indicate that Mario definitely isn't visible. You can do exactly the same thing for the top and the bottom. Now, if you think about this here, that effectively the tests that we have down here, for example, the first one, if the x-coordinate of Mario minus half of Mario's width, which is his left-hand side, if it is less than or equal to the center of the viewport plus half of the width, which is the right-hand side, then that means that Mario is potentially visible. If that condition wasn't true, then it means that Mario is somewhere off to the right outside of the viewport. So effectively what we have here are 4 if statements, and if all of them are true, it means that Mario must necessarily fall within the viewport. It is worthwhile maybe getting a piece of pen and paper, sitting down, and just to go through a few conditions here, to draw a few sort of objects relative to a viewport, and to ask if they're tops and their bottoms and the left and the right, where are they relative to that particular viewport. Hopefully then you'll see that this will hold true. Now, previous slide, it probably was difficult enough in terms of getting your head around it, but there are other things here which are going to make this, which seems to be a fairly simple thing, working out, okay, we've got a window into our world, if something's visible within it, let's draw it on the screen. But there's going to be one thing that will conspire to make this actually quite conceptually difficult, and it is something that I think quite a lot of students have found difficult to get their head around initially, because we're going to be looking at things from different perspectives, but we'll have a look at this now. Here's a definition from actually the Android Rect class, and when we're drawing things out, we will be going to our canvas object, drawing our bitmap, passing in rect objects or matrix objects, but rect we'll be using here for working out our source and destination images. So rect holds 4 integer coordinates for a rectangle. The rectangle is represented by the coordinates of its 4 edges, left, top, right, and bottom. Now, reading this out, I want you to think, does it contain anything that is rather curious? These fields can be accessed directly. Use width and height to retrieve the rectangle's width and height. Note, most methods do not check to see that the coordinates are stored correctly, i.e. left is left equal to right and top is left equal to bottom. There's a curious thing in this definition, and it's in the note that we have at the end. In particular, top is less than or equal to bottom. If we're thinking about left and right in terms of, say, our x-axis, the left point is normally a smaller coordinate than the right point. That makes sense. and the top point. Normally you would think the top of something to be greater than the bottom, but the actual condition here is that the top is less than or equal to the bottom. So this can be counterintuitive. And the reason we have this is that when we are specifying pixels or texels, so images on the screen or images as part of the bitmap, the convention is that 0, 0 is the top left, x, positive x goes to the right, and positive y points to the bottom. It goes down. So in that particular case, if we're thinking about a rectangle in terms of its top left and bottom right locations, the y coordinate of the bottom location will be a greater value than the top of the rectangle. And that's going to be key. This is what we're going to have to keep in mind. Where it gets confusing is that if we're thinking about our game world, it's most convenient for us to think about our game world where y points up. And if you move up the y coaxis, you're moving up the screen. And we should do that, because otherwise it's a strange way to think of your world. But we're going to have to be careful that we convert from, if you like, our layer coordinates into our bitmap or pixel or screen coordinates appropriately, and always remember to do that conversion. So let's have a look then about how do we work out which region of the bitmap falls within the viewport. And we're going to do that as a rectangle, and then given that, we will be able to draw. That's going to be our source rectangle, the region that we will be drawing out to the screen. So I'm assuming here we've got our usual viewport and our image. We've got a center point, like a width and height. This is how I'm assuming we have the two aspects defined. In terms of the image that we're drawing out, and if you look closely at Mario's image here, you'll see that 0, 0 is the top left location, and it has an image width and it has an image height. So this is where we're getting into these two different ways of viewing or thinking about locations. So we want to work out the region that's within the viewport, but then to express that in terms of the region of the bitmap that we will be drawing out. Thankfully, I mean, I'm going to show you little fragments of code here. It's not as difficult as you might sort of initially assume. The first one is we want to work out, well, where do we start from? Where's our source X? So this is the source X in terms of our particular bitmap, but here it is whereabouts in Mario are we drawing from? Where do we commence? You can see for the particular instance that we have shown on the screen that Mario starts a little bit off the screen. So our source X is not going to be 0, it's not going to be the start of Mario, it's going to be a position into Mario just as Mario becomes visible within the viewport. If Mario was fully within the viewport, then our source X would be 0. We just start from the beginning of Mario. So all we're doing here is we're working out, it's going to be a maximum of 0, and here we're looking at, so it's the viewport minus half of the width, that is the right hand location, sorry, this is the left hand location of the viewport, and we're taking away from that Mario's left hand location. So we're looking about along the x-axis, where does Mario start, where does the layer start? If if Mario starts before the layer, then we want to work out, well, what is the difference between the two, and that is what we use as our starting x coordinate. We're doing something exactly the same for the y coordinate that we're looking at, where Mario's height starts and where does the viewport start in terms of its height, and doing exactly the same principle for this, but we're taking into account the actual directions of positive y that we've talked about here. So we work out the source x and the source y. Fairly straightforward, simply based upon where the image starts relative to where the viewport starts. Given x and y, the next thing we need to work out is the width and the height. And this is ever so slightly more complicated, but not really. If you have a look at the piece of code that we have here, we've got a number, first of all, Mario width minus source x, and we're taking away from that another variable that looks very sort of similar calculation to the one up above. Now, our source width. This is how much of Mario, how much of the image we're going to draw across, how much of Mario actually falls within it. If, when we were thinking about our starting X location, if Mario was within the image, then potentially the width is going to be the whole of the image. So Mario.width minus source X. So if it was 0, if Mario starts within it, then we're prepared to draw the whole thing. If, however, that Mario started a little bit outside of the image, as we have an instance here, then we can't draw the whole width. We need to take away from that the bit that falls outside of it. So Mario width minus source X basically works out, okay, right, take away the bit that falls before the viewport, how much of it actually falls within it, or potentially falls within it. The second line, which is the maximum of Mario.x plus Mario.width 2 and then the width in X, this works out, okay, we know, we've worked out how much potentially fits within it, but Mario could actually end outside of the viewport. So we're thinking about the x-axis here. The right-hand side of Mario is potentially beyond the right-hand side of the viewport. It isn't in this example, but it could be. So what we are taking away then is the region of Mario that falls outside of the viewport. Now, if Mario was completely inside the viewport, then the source width will simply be the width of Mario. There'd be no difference. If Mario was actually wider than the viewport and sort of started outside of it and finished outside of it, then we would be chopping off those respective bits. So we do that for the width, and we do more or less exactly the same thing for the height. We're interested in working out how much of the height of Mario we draw, again chopping off any bits that either fall above or below the viewport. Now, once we've done this, we've worked out our starting location where we start drawing from. We've worked out how much we want to draw, and that's almost it. The last thing we have to do is to remember that we're talking here in terms of layer coordinates. Our bitmap may be of a different size, that one layer coordinate may not be the same as one pixel within the bitmap. So we work out a scaling factor between the actual width of Mario in terms of layer coordinates and the image that we have available to draw out for Mario, because ultimately it's the image that we're drawing, so we want to scale that so that we're capturing the right bit of the image. So we do scaling along the X and the Y, and then finally we can work out our source rectangle, where we're taking the source values that we've calculated and we're simply scaling them based on the bitmap. A fair amount of stuff has happened within this here, but each step on its own is reasonably simple, reasonably logical. We're simply just piecing them together. Having worked out which bit of the source image we're drawing, we then need to work out, well, where are we drawing it to? So what is the destination rectangle on the screen that we want to copy our source bitmap segment to? So if we're doing this, it's actually going to be something fairly straightforward and fairly simple. We will first of all work out, okay, we have a layer size, so we know how big our viewport is within the actual game world itself. How big is the screen viewport in terms of the number of pixels that we're drawing to on the screen? They may be a different scaling factor. So there we're going to work out that to actually scale from the layer, the game world, onto the screen, what is the scaling factor along the X and along the Y? So similar to the bitmap, but just simply scaling between the world viewport and our screen. Having done that, we then do something very similar to what we did with the other one. Effectively, it's more or less the same type of calculation. We're looking to see, okay, what region then of Mario, where does Mario begin relative to the screen? More or less exactly the same calculation as before. This time we're just looking at it in terms of the screen's perspective. We're scaling it by the x-axis of the screen. And we do exactly the same for the y. So this is no different than the calculation before. We're just simply including within it whatever scaling we need based on the screen. Now the width and the height, we already calculated those prior, so again all we're doing there is we're taking the value we calculated prior and we're multiplying that by the scale that we have on the screen itself. So we've already done all the hard work, we're simply just repeating it here, working out for our screen rectangle how that should look. So by way of summary, you work out if the game object falls within the viewport. If it is within the viewport, then you work out what region of the bitmap that you have for that image should be drawn, and you also work out the region of the screen that you're drawing to, and then finally you draw it. So reasonably straightforward. There's a few factors that can make life a little bit more complex on a tablet. One of them is to do with different aspect ratios of the devices that we may end up using. So we'll have a look at this now. There's not one fixed aspect ratio, there are lots of different types. You have 4:3, so that's one that Apple tends to favor for its iPads. You also have 3:2, again for the Microsoft, the Surfaces, most recent one, or for some of the Android tabs, they generally use that, or have used that particular aspect ratio. And you also have 16:9 and 16:10, and quite a lot of the Android tablets will use that particular aspect ratio. So there's not one ratio, there's lots of different screen ratios that have been used, and there'll be other ones beyond the sort of the semi-standard ones you have shown here. This matters to a game because depending upon the aspect ratio of the device, you will be able to display vertically or horizontally more or less of your game. And you can see the distinction here that if you have 4:3 or a 16:9, that there's different amount of space available along the X and the Y axes. As a little bit of general advice, if you assume a 3:2 aspect ratio, that's a good sort of safe one to assume. Then the other views, they just simply give you additional horizontal or vertical space. So 4:3 gives you a little bit of vertical space, and 16:9 and 16:10 they give you some additional horizontal space. But 3:2, if you like, you can view that as your core game area that you will design the game around, and the other ones are just sort of bonus space that you have available. So quite often you might have a virtual viewport, your layer or your game viewport of say 480 by 320 landscape, or 320 by 480 if it is in portrait mode. So what do? You've created your 3:2 aspect ratio, you're running on a device that actually has a different physical aspect ratio. What do we do as a consequence of that? There's different ways of handling it. One approach is to simply stretch what you have to whatever aspect ratio you're drawing to. You can also use black bars, so you can say, okay, I'm just going to draw a 3:2 region, and the other regions I'm going to leave black, I'm not going to actually draw to them. Or you might say that, okay, I have my 3:2 aspect ratio, I'm going to use that for the game, but when I'm drawing it, I'm going to use a slightly larger aspect ratio to sort of capture this additional space. But I've designed my game to work on 3:2, so I know where I put all of the controls and all of the key information relative to that. This is just some additional bonus space. Using scaling, using black bars, you're guaranteed you've got the same amount of information displayed in each device, although it is likely to impact on the visual aspect of it one way or the other. It may sort of look stretched, or the black bars for some people may look sort of not appealing. If you resize the viewport, then you're making full use of the screen. That's a nice thing. It does mean in some devices, or in different devices, you may see different parts of the world. So you need to make sure you've designed it, that additional bonus space that you're displaying is showing something that's sort of meaningful or useful to it. So by way of a couple of key takeaways and all of this, viewport, very useful. It enables us to determine the part or the region of the game world that we want to display. And it is straightforward, the process of working out, is it visible? If it is, pick up the source region, work out the destination region and draw it. The coordinate systems and variation between the coordinate systems, that's the thing that conspires to make this a little bit more difficult than ideally it ought to be. But with that in mind, once you get through that, it isn't too difficult overall.